in Zoom you can record, but the in Zoom the free time is 40 minutes. Okay. In Google Meet, you cannot record with the free version. If you have to record, then you have to pay money. It is not free. And what else is there? Yeah, these three are the things. Okay, I'm waiting for others to come. So Chaltha came, but he left.
Sir,
Uh,
what about the YouTube? YouTube we can see afterwards.
YouTube, yes, but I have not tried. I have never tried in YouTube video. Maybe I can trial once, and we can see how it goes. But yeah, I have to try actually. So yeah. So let us see today how it goes. Then we'll try.
Yes, sir.
Okay, will others join? Will others
Sir, they are
join?
about to join.
Okay, I'll wait for them. So actually, so only this is the one that now which gives us 50 minutes of our free recording time and also recording facility.
Yeah.
So anyway, first I would like to share the content, like the what is it called? Your syllabus. This so your syllabus.
Yes.
What to do this height? Okay. So yeah, this is the syllabus, and I will take the whole paper. It's a 4 credit paper. So I think we can wait for a few more minutes. Then I can give you an introduction. Okay. So the thermal physics, it's mostly like thermodynamics, heat and thermodynamics.
Sir, which unit you will be taking first?
Oh, unit one. I will start from unit one. Is there a way to go back to the video? So actually, I am also learning about this platform. Uh, okay, we are still two people. So can you see this course code BSP 302? Can you see this?
Yes, sir.
Yeah. Okay, so Chaltha has come. Okay. So Chaltha, why are you mute? Unmute.
Oh, sir. No, I just got a problem. That's why.
Oh. So why did not you appear in practical Viva? Huh? You should have appeared.
Yes, sir. It's with me.
Okay, so I think okay. If they come, I will allow them to enter.
Sir, Panchi will also come. She is downloading the app. Please.
Oh, okay. So yeah, actually I asked you to download quite. I know we had exam. Actually, I'm also new. No? I'm also learning some features. So anyway, uh, yeah. So Google Meet is very easy to use, no, because most of us have Gmail accounts and we can easily sign up. And but here you have to create an account separately. Okay, so I start. Let them come. I will admit them one by one. Okay, so good afternoon and welcome to your first class of. Okay, so Sadiq wants to join. Hello, Sadiq. Okay, so okay, welcome all. Welcome to the first class of the paper code is P302, and the paper is thermal physics, which is a 4 credit paper. Okay, so may I request all of you, you mute yourself, but you show your, you turn on your video. I think that is also
Yes,
in
sir.
the code of conduct, right? So you mute yourself and turn on your video. And if you have any question, you can of course unmute and you can ask the question. Okay. Okay. Yeah. So okay. So thermal physics paper, which is a 4 credit paper, and by now I hope you know what is 4 credit. It means total marks is 100, 70 marks
You
from.
see me, sir?
Let me check. Oh, where is the video panel done? So actually, video panel I have to find it here and there. Anyway, so it's okay. So no problem. So I lost the video panel actually. Where is it? Let me check how to do return to meeting. You have already learned the meeting. Do you want to do the same meeting again? No,
Sir, what?
no, nothing. I was seeing a message on. Okay,
Yeah.
okay. So unmute all, mute all. Okay. So I lost the video panel. Anyway, so let us start. Okay, this is the syllabus you can see. So what you will learn here, your course outcome is okay. Okay, I can find the video panel. Yeah, I can see Sadiq. Sadiq, I can see, and others I don't see yet. Anyway, so let us start. Okay, so what you will learn course outcome. So upon successful completion of the course, you will be able to learn basics of thermodynamics. Okay, learn about various quantities related to thermodynamics such as entropy, thermodynamic potential, etc. We'll learn about Maxwell's thermodynamic relations. We'll learn about kinetic theory of gases and molecular collisions, and we'll learn about real gases. Okay, Chalta, can you mute yourself? Okay, I have muted. Okay, so these are the things we will learn. You can see, and in Unit One, so it will be mostly introduction to thermodynamics, basic introduction. Unit Two, okay, so in Unit One, we'll learn about like what are zeroth and first laws of thermodynamics. Okay, extensive, intensive properties like the concepts of heat, work, this various quantities like specific heat at constant pressure, specific heat at constant volume, work done in isothermal processes, work done in adiabatic processes. Then we learn about second law of thermodynamics and the very important topic which is Carnot cycle, Carnot engine, etc. Then second law of thermodynamics, the different statements we'll learn about. Then Carnot's theorem we'll learn. So then we'll learn about some scale of temperature like that. Okay. Okay, then in Unit 2, we'll learn about entropy, concepts of entropy, then Clausius theorem, Clausius inequality, second law of thermodynamics, etc. Then in the second part of Unit 2, we'll learn about thermodynamic potentials like internal energy, enthalpy, Helmholtz free energy, Gibbs free energy. Okay, then the properties and applications, and then magnetic work, cooling. Cooling due to adiabatic demagnetization, then first and second order phase transition, then process Clapeyron equation and Rn phase equation. These things we'll learn. Okay. So am I audible to you? So can you hear me? Yeah, yeah. Okay. I am audible.
Yes, sir.
Okay. Then in the third unit, we'll learn about Maxwell's thermodynamic relations. Okay, very important thing, very important
Wait,
topic.
sir,
Huh?
hello, sir.
Hmm.
Sir, how to make the full screen, sir? I'm not getting. I'm not able to view this in full screen, sir.
Full
How to make
screen.
this in full screen?
You are online from mobile.
Yes, sir. On my mobile. Yes, sir.
Can you like take your mobile in the landscape mode? Landscape mode means like this mode, not this, but this.
Yes, sir. Yes, sir.
Okay, now you are tilted. Yeah, yeah. Now it looks better. Yeah, with the landscape mode, you look better. So others may also come online for video. I'm recording this
Actually,
video.
sir, like
Huh? Hmm?
yes, sir. Like the screen you are showing now,
Yeah.
that screen, if I can see in the full screen, sir, I'm not able to get that. How to do in the full screen? That only. Like how to make that in full screen?
Oh,
Because you are showing the screen, na, sir. I am not able to find any button like or any option to make it in the full screen because I can't see
actually,
what is there in the
I
screen.
am not. I also don't know much about the mobile,
Okay, sir.
but it is
Yes, sir.
always for me. It is always convenient to do the meeting from laptop.
Yes, sir. Sure, sir.
Mm.
I will do.
Uh, okay, so Raihan does not have enough charge. It's okay, so no problem. But I am recording this. Okay, recording this means I will see how the recording goes on, like how big is the file. So I will also just check some technicals related to this video. Okay, and the video is I think limited to 50 minutes. Okay, so 50 minutes for free we can do, and we can also record for maybe 50 minutes. Then I'll see how big the recording is. Okay.
Yes, sir.
Okay, so moving to the unit 3. In unit 3, we have Maxwell's thermodynamic relation, then derivation of Maxwell's thermodynamic relations, then application of Maxwell thermodynamic relation, Clausius-Clapeyron equation, the Cp minus Cv value. So Cp minus Cv value we can also do from Maxwell's thermodynamic relation, and we can also do it from our knowledge of this work and heat from unit 1. Then TDS equations, so these things also we will learn. Then kinetic theory of gases we will learn. Okay. So these are actually ideal
Yes, sir.
gases, no? so most of the things here we'll learn are ideal gases, because in the unit 4 we'll learn about real gases, and you perhaps know that there are some differences between real gas and ideal gas, and which time we'll be learning more about the differences and various things related to real and ideal gases. Okay. So kinetic theory of gases will learn Maxwell-Boltzmann law. Then this root mean square velocity, mean velocity, most probable velocity, degrees of freedom, law of equipartition of energy, so on. Then we'll learn about molecular collision and various phenomena like viscosity, thermal conductivity, diffusion, Brownian motion, and significance. So these things also we'll learn. Then in unit 4, which is the last unit, we'll learn about behavior of real gases. Okay. So this time our topic will be changed. So real gases. Okay. And what are the real gases? What are ideal gases? That difference we'll also learn in the meantime. Then we'll learn concepts of Boyle's temperature, then van der Waals equation of state. Okay, then PV diagram for adiabatic expansion of perfect gas, Joule function, porous plug experiment. These are the things we will learn. Okay. Okay, so this is the overview of your syllabus that we are going to learn. Of course, we'll start from unit 1, or the easiest part of your syllabus. Then some textbooks are given here. So a few books may be available in library also, like heat and thermodynamics, Zemansky's book. Then this book is also quite good, Meghnad Shah and Srivastav. Then I think this book we should have in the library, this thermal physics book. Okay. And Kumar and Taneja, this book may also be there, but I am not very sure, because right now we cannot access library, so we are not very sure. So what some books are there in library for sure, but I forgot the name exactly which book. Okay. Okay, so this is all about your overview, and so introduction to thermodynamics. Although I am not sure if I have the notes with me right now or not, I will check. But from the next class, we will be regular with your class notes. Okay, and notes will be also uploaded to a Google Classroom separately. So in a class, we will discuss mainly the like theoretical parts or conceptual parts. We'll discuss, and but the notes I will upload them to your Google Classroom, and the Google Classroom link I will share with you very soon once I start uploading the notes. Okay. Okay, so zeroth law of thermodynamics.
Sir,
So, any question you have?
sir, sir, you will make one new classroom, na?
Yeah,
In
yeah, I will share the link, etc. Not the previous one, not the previous one. New one, the link I will share. Okay, zeroth law of thermodynamics. Let me just give a small, because this is very easy easy to understand concept. Let me try to find some picture. I will explain from picture. So today just some we will give you some overview of the topics, and then which one I can take. Okay, so can somebody? Okay, I am stopping this sharing, and I will share another thing now. Okay, I think you can see this thing. Can you see this A equal to B equal to C?
Yes, sir.
Okay. So this comes while we will talk about zeroth law of thermodynamics. Okay. So um, okay. So what is thermal equilibrium? So can you tell me? So do you know what is thermal equilibrium?
So when the heat exchanges in equal forms, or when the input heat and the output heat is there equal, whether constant.
Yeah. So thermal equilibrium means the temperature of two bodies are equal. Suppose one is at 100 degrees Celsius and the another body is also at 100 degrees Celsius. So their temperatures are equal. Okay. So you see here A, the body A is in thermal equilibrium with B. If I say that the temperature of a body A is equal to the temperature of a body B, in that case, what we say that in that case we say that A and B are in thermal equilibrium. Okay, A and B are in thermal equilibrium means what? The temperatures of the body A and B are equal. Okay. Similarly, now you come. What does it mean? A and C. A and C means A and A equal to C. That means the temperature of the body A is equal to the temperature of the body C. Okay, that means A and C are also in thermal equilibrium. Or in other words, if A and C are in thermal equilibrium, that means that the temperature of the body A is equal to the temperature of the body C. Now, do you understand this? I hope you understand. Okay. So, what are the two
Yes.
conditions we have? The two conditions are the temperature A is in thermal equilibrium with B and A is in thermal equilibrium with C. That means A is at the same temperature with B and A is also at the same temperature with C. In that case, what will happen? B will also be at the same temperature with C. Okay, that means B and C will also be in thermal equilibrium. Okay, so have you understood this? Suppose in algebra mathematics in high schools you have got, no? Yeah, in algebra mathematics, if x equal to y and y equal to z, in that case x is also equal to z, right? In high school mathematics in algebra you have learned those things. So here also this is the same thing. If a equal to b and a equal to c, then b equal to c. Okay, but here which particular quantity we are talking about? The particular quantity we are talking about is temperature. That means if the temperature of A is equal to the temperature of B and separately temperature of A is equal to the temperature of C, in that case the temperature of B will also be equal to the temperature of C, and nothing but this is the this is the zeroth law of thermodynamics. Okay, so I just want to show you the statement of zeroth law. So there are many figures in internet. So today I could not provide you note, but I hope I can show you some documents from the internet. Of course, I will give you very no standard notes on these things, but I will start uploading them slowly. Okay, so I hope you can you see this statement? I think it will be clear. The zeroth law states that if two systems are in thermal equilibrium with a third system, they are also in thermal equilibrium with each other. That means two systems are in thermal equilibrium uh, with a third system, okay, then they are also in thermal equilibrium with each other. So here B is in thermal equilibrium with A and C is also in thermal equilibrium with A. That is what two systems are in thermal equilibrium with a third system. The third system is A. Then they are also in thermal equilibrium. Then that means B and C will also be in thermal equilibrium. And basically this is the zeroth law of thermodynamics. Okay, have you understood now this? I think this is very easy to remember, very easy to remember statement of this law, zeroth law of thermodynamics. Okay. Okay. Anyway, I'll provide you notes soon. So in internet there are various illustrations of zeroth law of thermodynamics. And yeah, another definition may be there, or you may be asking question, a short question, of course. So the question may be like this: when I mean, what do you mean by thermal equilibrium? Okay, what is the definition of thermal equilibrium? Or in other words, the question may be also asked like, when are two things or two bodies, when are two bodies said to be in thermal equilibrium? So either way, this question may be asked. Okay, so answer will be same. The two bodies are in thermal equilibrium. So when the temperatures of both the bodies are equal. Okay, so that is the definition of thermal equilibrium, and the zeroth law of thermodynamics can be stated from the definition of thermal equilibrium. Okay. Okay, so just after giving you some overview on thermal equilibrium, so I'm going to first law of thermodynamics. So I think you already know what is first law of thermodynamics. You have read in your class 11. Let me try to find some figures, good figures from internet. This is just for revision purpose. Let me find a proper definition. Let me check. No, this is the limitation. So not this. Just try to find a good. What is this? Okay. So here one article link I have got. Okay, the internet is downloading actually. Yeah. So what is the first law of thermodynamics? So okay. So the change in internal energy, so the statement is written like this here. The change in internal energy of a system is equal to the heat added to the system minus the work done by the system. This is the change in internal energy is equal to heat added to the system minus the work done. Or in other words, how you can define thermal energy. So, from your class 11 concept, so do you remember the law, the definition of first law of thermodynamics? Can anyone say what do you remember about the first law of thermodynamics?
Sir, first law, I think it was on the law of conservation of energy, sir.
Yeah, exactly. So, just how did you learn the definition in class 11? If you remember, of course, we are going to learn this semester also.
And
He can neither be created nor destroyed. He can neither be created nor destroyed.
energy
Uh-huh.
can neither not be destroyed.
No, no,
Energy
that,
can neither be created nor be destroyed,
But
but
can
it can only be transferred
converted
from one
from
system
one
to another.
form to another.
yeah, energy can neither be created nor
Can neither
destroyed.
be created, not
Yeah, that
destroyed.
is the general law of conservation of energy. But the first law is, yeah, first law is also a form of like conservation of energy, but it is a bit different. So you can see the definition here. So okay, I am just telling you the definition, and you tell me if you recall it now or not. Okay. So if you supply heat to a system, heat is a form of energy. If you supply heat to a system, then that heat is utilized in two ways in the system. What are those two ways now? The two ways are, one part,
Work and internal energy.
yeah, one part is used up in increasing the internal energy, and the other part is
Work
utilized
done.
in doing work by the system.
Work done.
Okay. So one part in one part in increasing internal energy, and the other part is utilized in doing work by the system. So now, what is internal energy? How do you define internal energy?
The
What do you mean
energy
by?
of
So we are talking
the
about internal energy. What does that mean? What do you? I mean, what do you think about this? Like, what is your concept of internal energy?
Sir, the heat possessed by the system.
Uh, Heat possessed. No, not exactly.
sir energy is at a very small, like molecular level. Those are
Where the kinetic energy of the molecule.
Yeah, mostly related to that. So it is the total energy in the system. Like, these atoms, molecules, no, they have some kind of like thermal vibration. No? Due to heat, they are moving about their mean position. So, okay, so maybe at room temperature, that is not very much observable. But as you increase the heat of a system, the atoms, molecules, and the constituents of a material, they begin to move like no vigorously, or they gain what kinetic energy. Initially, maybe they have potential energy. You know, potential energy. Potential energy is due to the position or configuration of a system, and kinetic energy is the motion of a body due to the motion of an object. So, internal energy is more or less like the summation of potential and kinetic energy in a system or in a body. Okay. Now, if increase in internal energy means increase in the kinetic energy of the system of the body, because they are getting heat and they will have to adjust to the heat of the system. Okay. So understood that now. So yeah, so it is the total heat, like total energy of a system. Okay, internal energy. And if you're supplying heat, that internal energy, I mean that the energy processed by the object will increase. Okay, that is why they are using delta U. You can see here, this is they are writing delta U. Delta U means the energy is not same, that energy is changing or increasing. Okay, so it is not a fixed quantity, but it is a changing quantity, and it is changing, of course, because you have supplied heat from outside. Okay, now can you tell me, if you do not supply any heat, or if you do not, like, if there is no temperature change, what will happen to internal energy? If there is no temperature change in a system, what will be the effect
sir, it will
on
be zero.
yeah, exactly, the change in internal energy will be zero. Okay, because you are not supplying any heat or no. uh, temperature change, that means there will be no change in internal energy. And work done by the system. The second quantity is work done by the system. So anyway, work done by the system, W has a formula which is PdV. Okay, P means pressure and dV means change in volume. Okay, so dV is change in volume. I mean the system is initially at one given volume, but later when you supply a heat, the system's volume will increase. Okay, like most of the solids, liquid, what is happening? Their volume is increasing. Suppose they are earlier at volume V1, later their volume will be V2. Okay, therefore the change in volume will be positive. And so work done by the system, PDV is the quantity to represent this expression W. Okay, so that those are the two ways how the energy or heat supplied to a system is utilized. So one part is utilized in increasing internal energy, that means the increasing the energy of the constituent atoms and molecules, total energy of constituent atoms and molecules of the system or of the body. And the other part is the body itself will do some work. How it will do the work? It will do the work by increasing its volume. The body will increase its volume and it will do some work. So these are the two different ways by which the heat supply to a system is utilized. Okay. And more or less, this is the statement of first law of thermodynamics. So we'll also I also give you notes, etc. Okay. So yeah, more or less, this is the first law of thermodynamics. Very interesting topic. So next, let me see what else is there. Then zeroth law. Okay, then extensive and intensive properties. Intensive thermodynamic variables are there. Then thermodynamic equilibrium, we have learned zeroth law, thermal concept, state function, first law of thermodynamics. Yes, okay, and its differential form. Then specific heat at constant pressure and volume. Okay, yeah, work done in. Okay, yeah. So this actually your this course is going to be a lot of mathematical, a lot mathematical. So a lot of mathematical derivations etc. will be required. So anyway, I will discuss in class and also will be given to you in notes. So okay, next quantities extensive and intrinsic variables. So what do you mean by that? So today just I am giving you introduction. So it's like note wise we can start from the next class. I think this is a very good table given here, or this figure. Let me see this figure. Yeah, so I hope you can see this figure. What are intensive properties? What are extensive properties? So first, I start with extensive properties. So extensive properties depend on the size, mass, dimension, on those things. Okay, like mass is an extensive property. So size is an extensive property. Volume, weight, length. So these are all these things are included in extensive properties like volume, mass, size. So volume of a same material may be different. Mass of a same material may be different. Okay, like in your class maybe some student is I'm not, I don't want to take anybody's name. Maybe some student is fat but some student is thin. Some student may be tall, some student may be short. So just try to understand those are extensive properties. Okay. So you all are like human beings. Okay. So we all are human beings, but we have different mass, volume, size, weight, length, etc. These things. No? Also, it is true for materials. Okay. But intensive properties are more or less like the characteristics of materials. Okay, like boiling point, color, temperature, luster, hardness. Okay. Now, if I consider like what to say, um, mm, suppose a piece of iron, maybe not a piece, two pieces of iron. One may be 50 centimeter long iron rod and another may be 1 meter long iron rod. Okay. So the hardness, no, you see one of the properties is the hardness here. So the hardness, will it change with the length of the material or with the size of the material? Will it change? No, it will not change. Why? Because the material is same. So irrespective of the length of the material, so irrespective of the length of the material, the hardness of the material will remain the same. Okay. Okay. So one thing that in 5 minutes the meeting will end. Okay, because maybe I started a few minutes before to test today, and also this is a free version of WebEx, so it has 50 minutes of time. Okay. So just for information, so the meeting is going to end soon. Okay. Okay. So boiling point. Now, if we take water, no, suppose you take 1 liter of water or you take 100 ml of water. So, will there be any change in boiling point of water depending on the amount you are taking? So, 1 liter of water will also boil at 100 degrees Celsius, or 200 milliliter of water will also boil at 100 degrees Celsius. So, that means the boiling point of the material remains the same irrespective of the amount you are taking. So those are intensive properties. Okay. So extensive properties are like the same material may have different length, mass, weight, size, volume. And intensive property is like the material may have different volume, mass, size, length, weight, but their properties, their inherent properties will remain the same, be it color, be it temperature, be it luster, hardness, boiling point, melting point. So whatever you say, those properties will remain the same irrespective of how much amount of material you are taking. Okay. So I think this was a brief idea about intensive and extensive properties. Okay. Yeah. So I think from next class I maybe I will start PowerPoint. I don't know. I will have to explore some more things, and notes etc. also will be given. Okay. Okay. I think it's all for today because in a few minutes our meeting will end because okay, I'm stopping the share. In a few minutes the meeting will end, and I hope to see you in the next class. So your exams are over, all exams.